Guys, today I'm going to present a video on design of doubly reinforced beam section. In the previous video we have seen the basics of doubly reinforced and how to design the doubly reinforced beam. Let us take a glance. So this is the section with compression reinforcement. In this case, if mu is exceeding the limiting value, we have to go for doubly reinforced sections. That is, mu minus mu limiting is equal to fsc into asc into d minus d dash. For limiting moment of resistance, we have to find out the ast value by using mu is equal to 0.87 fy ast into d into 1 minus fy ast by fck pd. By using that formula, we have to find out the ast1 value. After getting the ast1 value, we have to calculate the ASC value by using this equation, that is mu minus mu limiting is equal to fsc into asc into d minus d dash. By equating, we will get the area of steel in the compression zone. For finding out the fsc value, we have to find out the epsilon sc value by using this formula, that is 0.0035 into xu max minus 3 dash by xu max. The xu max values are given in IS456 for different grade of steels. After finding out the epsilon sc value by using stress strain curve for cold work with deformed bars, we have to calculate the fsc value. After finding out the fsc value, substitute all the values in this equation, we will get area of steel in the compression zone. After getting the area of steel in the compression zone, we have to find out the AST2 value, that is by using this equation, AST2 is equal to FSC into ASC divided by 0.87 Fy. So ASC value, we will get this value in this equation, and FSC value we already find out by using this epsilon SC value. Substitute all the values, we will get AST2 value. Then calculate the total AST, that is AST is equal to AST1, which is from limiting moment of resistance, and AST2. By using this equation, we will get the total area of steel in the tension zone. Let us see an example how to design a doubly reinforced beam section. This is the example we are going to solve in this session. Rectangular RCC beam of width 400 mm, effective depth is 600, is to be designed to support a ultimate moment of 600 kN meter by using M20 grade concrete and Fe415 steel, and let us assume the effective cover as 60 mm. In this case, small b is equal to 400, small d is equal to 600, and mu, that is ultimate moment, is equal to 600 kN meter. And M20 grade concrete and Fe415 steel is used, and d prime is equal to 60 mm. So this is the given data, and first step is we have to calculate the limiting moment of resistance. For Fe415 grade steel, the mu limiting value formula is 0.138 FCK BD square. Substitute all the values of FCK, B and D values, we will get the mu limiting value, that is 397 kN meter. But in this problem, the mu value is 600 kN meter, so mu is greater than mu limiting. So in general, the section is over reinforced, but over reinforced sections are not preferable. So we will design this particular structure as a doubly reinforced section. So first we have to find out the area of steel for balanced section, that is for limiting moment of resistance. mu is equal to 0.87 Fy ast into d into 1 minus Fy ast by FCK BD. So let us equating mu is equal to mu limiting, that is 397 into 10 power 6 is equal to 0.87 into 415 into ast1. Here we are taking AST as AST1 because we are considering for only limiting moment of resistance. So into D is 600 into 1 minus Fy, that is 415, AST into AST1 divided by 20 into 400 into 600. By equating this, we will get AST is equal to 2297 mm square. After finding out the AST1 value, we have to calculate ASC value. So we have to find out mu minus mu limiting. That is, mu value is already given in the problem, that is 600 kilonewton meter minus mu limiting value, that is 397. So finally the balance moment we have to design is 203 kilonewton meter. So in the IS 4x6 2000, the mu minus mu limiting equation is equal to FSC into ASC into D minus D dash for finding out the area of steel in compression zone. So for finding out the FSC value, we have to calculate the epsilon SC, that is strain value we have to find out. So that is 0.0035 into XU max minus D dash by XU max. So in this equation, we have to find out the XU max value. For a Fe415 grade steel, the XU max by D value is equal to 0.48. So XU max is equal to 0.48 into D. We will get 288 mm. So after finding out the XU max value, substitute the XU max and the D prime values in the strain equation. We will get the strain value of 0.00277. After getting the strain value, we have to find the stress value, that is FSC value, by using the stress strain curve of cold work with deformed bars. So this is the cold work with deformed bar stress strain curve. So we got 0.0027, so nearly equal to 0.002. Let us take this line, straight line, and when it touches Fy by 1.15, just draw a line, straight line, and find out the stress value. Here it is approximately FSC is equal to 0.85 Fy. After finding out the FSC value, substitute the Fy is equal to 415. We will get FSC is equal to 350 Newton per mm square. After finding out the FSC value, substitute the values in mu minus mu limiting. We will get the ASC value, that is 203 into 10 power 6 is equal to 352 into ASC into 600 minus 60. By substituting, we will get ASC is equal to 1068 mm square. After finding out the ASC value, we have to find out the AST value. That is, AST2 is equal to FSC into ASC divided by 0.87 Fy. So substitute all the values and find AST2 value, that is 1041 mm square. Here we got two AST values, that is AST1 and AST2. So we have to find total AST, that is total area of steel in tension zone. AST is equal to AST1 plus AST2, that is we got total 3338 mm square. After finding out the AST value was also found out, that is 1068 mm square. By assuming the diameter of the bar in tension and compression zones, we have to find out the number of bars in the tension and compression zones. So here I am assuming 25 mm diameter bars in the tension zone. So we got n is equal to 6.8 numbers. So finally provide 7 numbers of 25 mm diameter bar in tension zone. By using 20 mm diameter bars in compression zone, number of bars is equal to 3.399. So provide 4 numbers of 20 dia as compression reinforcement. After getting the values, draw the diagram with all details. That is, B is equal to 400 mm, D is equal to 600, that is effective depth is 600, total depth is 660 mm, and D prime is 60 mm. Here we got